Engineers at the Jet Propulsion Laboratory hailed the Curiosity rover's successful landing on Mars 10 years ago. It was NASA's fourth robot to do so. In 2012, the Curiosity rover, which is now old enough to begin 5th grade, started its mission to investigate the possibility that life has ever existed on the red planet. The robot, which is roughly the size of a car, is equipped with tools for measuring the planet's temperature and geology. How well received was the mission? What can the Curiosity rover teach us about the past and potential future of space exploration? Over the course of its 10 years of Mars exploration, Curiosity has gone from Gale Crater to Aeolis Mons, colloquially called Mount Sharp. During its explorations, the rover has uncovered a plethora of knowledge about past climatic shifts, water and geological changes, and other variations. One aspect that sets Curiosity different is its size, which is comparable to a small SUV. It is around 7 feet high and measures 3 meters by 2.8 meters, 9 feet 10 inches by 9 feet 1 inch, 2.1 m. It weighs 2,000 pounds, 900 kilograms. The wheels of Curiosity have a 20-inch diameter, 50.8 centimeters. Engineers at NASA's Jet Propulsion Laboratory developed the rover, which can roll over obstacles up to 25 inches, 65 centimeters high and travel 660 feet, 200 meters every day. The heat produced by the radioactive decay of plutonium-238 is used to produce electricity by the rover's multi-mission radioisotope thermoelectric generator. Curiosity is equipped with a multitude of tools to help scientists better understand their surroundings. Opens a new tab. This includes Mast Camera, Mars Hand Lens Imager, and Mars Descent Imager are cameras that can take close-up pictures of minerals or the surrounding area, MARDI. A suite of spectrometers called the Sample Analysis at Mars (SAM) instrument suite includes the Alpha Particle X-ray Spectrometer (APXS), Chemistry and Camera (ChemCam), Chemistry and Mineralogy X-ray Diffraction/X-ray Fluorescence Instrument (CHEMIN), and Chemistry and Camera at Mars (ChemCam). In order to assess if humans and microorganisms can survive there, scientists use radiation detectors to measure the amount of radiation that is present on the surface. These are the Radiation Assessment Detector, RAD, and Dynamic Albedo of Neutrons, DAN. Sensors to monitor the surroundings to check the weather currently. This image displays the Rover Environmental Monitoring Station, REMS. The Mars Science Laboratory Entry Descent and Landing Instrument, MEDLI, was the main tool used during the landing. The rover has a few tools to check for habitability. One of these entails firing neutrons at the surface, which would cause them to slow down if they came into touch with hydrogen atoms, one of the elements in water. Curiosity's 7-foot arm may gather samples from the surface and burn them inside the rover while sniffing and analyzing the gases that emerge to discover more about the formation of the rocks and soil. The Sample Analysis of Mars device can corroborate this if it finds any indications of biological material. On Curiosity's front, there are several ceramic pieces that have been coated in foil and pumped with synthetic organic compounds. Curiosity may drill each of these blocks, and it can then grab a sample from each one and examine it in its oven. Researchers will then search for organics that shouldn't have been present in the block. If so, researchers will likely come to the conclusion that these are organisms that have strayed from Earth. The high-resolution cameras that surround the rover take pictures as it moves, providing visual information that may be compared to ecosystems on Earth. For instance, this was used when Curiosity found evidence of a stream bed. In September 2014, not long after a NASA science review advised that the rover focus more on finding out livable areas rather than moving, Curiosity arrived at its science destination, Mount Sharp, Aeolis Mons. It is currently climbing the slope while carefully studying the strata. The goal is to understand how Mars' environment changed from being wet to arid and acidic. The Curiosity Project scientist John Grotzinger made the following statement at the time: "I think the major advice of the group is that we drive less and dig more." The review's recommendations and what the science team intends to conduct when we are at Mount Sharp will be in sync. Curiosity's primary objective is to determine whether or not Mars is or was a place where life could exist. Even though it is not designed to look for life, the rover carries a number of instruments that can gather information about the environment. Scientists pretty nearly hit the jackpot when the rover transmitted data indicating that Mars had experienced habitable conditions. The first drill samples that Curiosity gathered contained powder that contained sulfur, nitrogen, hydrogen, oxygen, phosphorus, and carbon. These elements are all recognized as building blocks or necessary materials that could support life. Even if it is not a direct demonstration of the existence of life, the find intrigued the mission scientists. Michael Meyer, the lead scientist for NASA's Mars exploration program, stated that a key worry for this mission is whether Mars could have supported a livable environment. Based on what we now know, the answer is yes. Methane levels on Mars significantly increased in late 2013 and early 2014, peaking at about 7 parts per billion, compared to the usual 0.3 ppb to 0.8 ppb. Methane can occasionally be a sign of microbial life, therefore this was a noteworthy discovery. However, it could also be an indication of geological activity. However, the methane increase in 2016 led the researchers to believe that it was not a seasonal occurrence. Methane does, however, exhibit minute background variations that might be related to the seasons. Curiosity also made the first clear identification of organics on Mars, as was published in December 2014. Organics are regarded to be the basic building blocks of life. However, this does not mean that the presence of organics proves the existence of life. Even though the crew was unable to come to the conclusion that there was life at Gale Crater, NASA at the time stated that the discovery shows that the ancient environment supplied a supply of reduced organic molecules for use as building blocks for life and an energy source for life. Initial research results revealed that an unexpected method was utilized to detect complex chemical molecules in Martian samples carried aboard the Curiosity rover, as presented at the Lunar and Planetary Science Conference in 2015. 2018 Curiosity research findings added to the body of evidence supporting the possibility of life on Mars. In one study, more organic chemicals were discovered in rocks that were 3.5 billion years old, while in the other, it was shown that the amount of methane in the atmosphere varies seasonally. Although there is currently no conclusive proof that the gas is produced by living things, the seasonal changes would suggest as much. In January 2022, the rover found some intriguing chemical compounds on the red planet, according to scientists. A lot more research is required to substantiate the notion that the chemicals are proof of past life on Mars. Curiosity can also be expressed in another way. The official name of the Martian rover known to most people as Curiosity is the Mars Science Laboratory. It is commonly referred to only by its common name, Curiosity, due to how lengthy its full name is. NASA frequently uses both titles interchangeably, despite the fact that the actual project is the Mars Science Laboratory mission. The Curiosity's power system has significantly outlived its usefulness. On Curiosity, there is a radioisotope power system. This kind of technology generates electricity from heat created by plutonium's radioactive decay. A Martian year, or at least 687 days on Earth, have passed since this power source should have shut off, according to NASA. The 8 years that Curiosity has been roving around on Mars' surface provide evidence of its design. Curiosity's image of Mars contains 1.8 billion pixels. According to NASA, the 1.8 billion pixel panorama displayed in the video down below is the biggest and highest definition panorama the rover has ever captured. What's even cooler is that the panorama uncovered some important information about the origins of water on Mars. The Mars Science Laboratory mission tested a novel landing strategy. The arrival of Curiosity on Mars was a big development. It was the largest rover to ever land on Mars, and it tested a brand new landing mechanism. The new landing method entailed the spaceship initially parachute descending to the surface, see image to the right, taken by the Mars Reconnaissance Orbiter. Then, as a rope carefully lowered Curiosity to the planet's surface, the landing mechanism fired rockets in the final milliseconds prior to touch with the surface to hover over it. The landing system took off and fell into the Earth as the link was severed. Curiosity landed with its wheels down and is ready to investigate. The modified landing method was successful. The Curiosity rover served as the inspiration for NASA's Mars 2020 Perseverance rover. Perseverance, the forthcoming Mars 2020 rover, was allegedly patterned on Curiosity in an effort to lower costs and risks. Perseverance will search for signs of early microbial life in order to go further than Curiosity. The Mars 2020 rover from NASA will try to assess the historical habitability of the planet and search for signs of past life on the Martian surface. The question of whether there were favorable circumstances for life on Mars was the subject of earlier missions. Really exciting, huh? That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.